Navigating the high seas or managing operations in port, one of the most powerful and relentless forces a seafarer contends with is the wind. For those of us on bulk carriers, understanding its influence isn't just a matter of good seamanship, it's fundamental to the safety of our vessel, our cargo, and every single person on board. Today, we're diving deep into the significance of wind forces and how mastering this knowledge keeps us safe and efficient, both at sea and alongside the quay. Let's set the scene. Imagine you're on a Capesize bulk carrier, fully laden with iron ore, steaming at 14 knots from Brazil to Rotterdam. You're in the vast expanse of the Atlantic Ocean, about 400 nautical miles west of the Cape Verde Islands. It's 0600, and the officer of the watch notes the wind is picking up from the north-northeast, hitting 28 knots with gusts reaching 36. The swell is building to 4 meters. A look at the weather charts confirms your fears. A low-pressure system is intensifying right along your planned route. This is where theory meets reality. The master immediately recognizes the developing risks. The sheer size of a Capesize carrier presents a massive surface area to the wind, what we call windage area. This force can push the vessel sideways, a phenomenon known as leeway, forcing it off its intended course. As the vessel is pushed, it can also start to roll more heavily in the growing swells, increasing the risk of cargo shifting in the holds and potentially compromising stability. On the bridge, the conversation is focused and precise. The officer of the watch reports the conditions. Captain, surface, and synoptic charts indicate a low-pressure system moving west-northwest. Wind gusts are up to 36 knots from N&E. Swell is 3 to 4 meters. The master's response is immediate and decisive. Plot an alternative course to minimize the wind's impact. Adjust our speed to reduce rolling and leeway. He contacts the engine room, chief engineer. Prepare for ballast adjustments to optimize our stability. The team works in sync. The chief mate calculates the new route. A course change of 15 degrees to the south will reduce our exposure to the beam winds. Our ETA will be delayed by about 5 hours, but all hatch covers and deck equipment are secured. The chief engineer confirms readiness. Ballast has been adjusted, and the trim is optimized. The engines are ready for any speed modifications you need. Even the helmsman feels the change, noting, "Course altered, sir." The steering response is heavier now due to the gusts. The master's final instructions underscore the importance of continuous vigilance. Maintain a vigilant lookout. I want vessel behavior, wind readings, and chart updates logged every 30 minutes. Coordination between the bridge and deck teams is essential. This proactive approach, altering course, reducing speed, and adjusting ballast is a textbook example of mitigating wind-related hazards at sea. It's about choosing safety over schedule every time. Now, let's shift our focus from the open ocean to the confined environment of a port. Our bulk carrier has arrived safely in Rotterdam and is alongside, discharging its iron ore and preparing to load grain. While the vessel is stationary, the risks from wind haven't disappeared. They've just changed form. The port's weather office issues a forecast: crosswinds of 18 to 22 knots from the northeast, with gusts up to 30 knots. For port operations, this is a significant threat. Strong winds blowing against the side of the vessel can put immense strain on mooring lines, creating a risk of them parting. The gangway can become unstable and dangerous. And critically, cargo operations involving cranes have strict wind speed limits. Once again, effective communication and coordination are key. The chief mate reports to the master, "Captain, the updated charts show crosswinds gusting to 30 knots. This is becoming risky for our crane operations and mooring lines." The master's decision-making must now factor in terminal operations. Reduce the cargo transfer rate immediately. If gusts exceed 25 knots, suspend all crane operations. Ensure the deck and terminal teams are in constant communication. The terminal supervisor confirms their alignment. Will proceed cautiously at a reduced pace. All our staff are aware of the wind limits and will adhere to them. the safety officer on board reinforces procedure. I'll ensure all crew are using the correct PPE and lifelines, especially near the gangway. The team has been briefed on the situation. The bosun on deck confirms his team is ready. Deck team is monitoring the mooring lines closely. We're prepared to put out additional lines if needed. All crane rigging is secured. The master's final orders are clear. Monitor the wind and operations continuously. Log all updates. Make sure our emergency stop procedures are ready to go at a moment's notice. Import. The wind's force translates into pressure on moorings, cranes, and people. Suspending operations is not a sign of failure, but of a robust safety culture. To formalize this process, we use tools like a risk assessment matrix. At sea, a high wind causing leeway is a high-risk event. Control measures include altering course, reducing speed, and optimizing ballast. Import. Crane operations in high wind are also high risk. The control measure is clear. Suspend operations when wind limits are exceeded. A simple decision-making flowchart guides our actions. Observe the wind, calculate its true speed and direction, compare it to our operational limits, and then take appropriate action, whether that's altering course at sea or suspending operations in port. This entire framework of knowledge, understanding, and proficiency is backed by international conventions. SDCW requires competence in meteorology. SOLAS mandates safe voyage planning. The ISM code requires us to have procedures for weather-related hazards. Every decision we make is guided by these principles to ensure safety and compliance. So, what are the key lessons here? First, a deep appreciation for wind forces is non-negotiable for safe navigation and cargo handling. Second, proactive adjustments to course, speed, and ballast are our primary tools for mitigating risk at sea. Third, in port, safety must always take precedence over schedule, even if it means slowing down or stopping operations. And finally, continuous monitoring, clear communication, and meticulous logging are the pillars that support all our safety efforts. By mastering our understanding of the wind, we not only protect our vessels, our cargo, and ourselves, but we also uphold the highest standards of professional seamanship. Thank you for watching. Stay safe out there, and don't forget to like and subscribe for more insights into the world of maritime operations.